Hello everyone, welcome back to my channel Crack with Trick by Shiva. So today we are going to discuss about few questions from the topic sliding filament theory or mechanism of muscle contraction. So the topic that we were already discussed and uploaded in the YouTube channel. So those who haven't watched, they have to watch it. Anyhow, now let's go for the questions. Okay, a question from the chapter or question from the concept sliding filament theory. So the first question, which is actually what we are going to discuss, is it is actually from the NEET 2022 question. According to sliding filament theory, the thin actin filaments slide away from A band, resulting in shortening of sarcomere. Okay, once again, actin filaments slide away from A band, resulting in shortening of sarcomere. So what is the mistake in this? Okay, actin filaments slide away from A band. Okay, that is actually the mistake. Okay, it is towards the A band, resulting in the shortening of sarcomere. Now the second option, actin and myosin filaments slide over each other to increase the length of sarcomere. So that is actually, it is wrong. Why it is wrong? To increase the length of sarcomere, actually the sarcomere's length is shortened or decreases. Okay, now length of A band does not change. That is actually the correct, that we were already discussed, that H zone disappears, I band reduces, right? So that we were already discussed. Sarcomere shortened, but length of A band, or we can say that it do not change. Now I band increases in length. Of course it is actually wrong, because it is decreases in length. Okay, so this is the first question. So I hope you got an idea. Now the second question. Okay, the second question is also they have given, see, during muscular contraction, which of the event occurs? During muscular contraction, which of the event occurs? The first one, H zone disappears. That is correct, right? H zone disappears. A band widen. That is wrong, because A band that we were discussed that it do not change at all. Now I band reduce in width. Okay, I band reduce in width. So keep in your mind, I band it reduces in width. Now myosin hydrolyzes ATP, releasing the ADP and inorganic phosphate. So myosin hydrolyzes ATP. We have discussed that the head of myosin, it is having ATPase. Okay, binding site is there. So ATP will be attached there. It will be converted into ADP and inorganic phosphate. So during the muscle contraction, it will be converted into ADP and inorganic phosphate, and it will release the energy. That energy will be utilized for making that that bonding between the actin and myosin. Okay, so now here myosin hydrolyzes ATP, releasing the ADP and inorganic phosphate. Okay, now next one, Z line attaches to actin are pulled inward. Z line attaches to actin are pulled inward. Okay, so the Z line is present between the or in the center of actin, so which will also pull towards the center. Okay, that is why the sarcomere is getting reduces. Now what is actually the correct option? So correct option, we can say that H zone disappear. That is correct only. A band widen. That is wrong. We can say that I band reduces in width. That is also correct. Myosin hydrolyzes ATP, releasing the ADP and inorganic phosphate. That is also correct. Z line attaches to actin are pulled inward. That is also correct. So option 2 is the correct answer. Okay, now see the next question. See, next question, it is actually related to the same content only. Now the question is actually see, actually it is related to the same concept, sliding filament theory or mechanism of muscle contraction. So here sliding filament theory can be best explained as, sliding filament theory can be best explained as, first option, when myofilaments slide past each other, myosin filament shorten while actin filament do not shorten. That is actually wrong. When myosin slide past each other, actin filament shorten while myosin filament do not shorten. Actin and myosin filament shorten and slide past each other. Actin and myosin filament do not shorten but rather slide pass each other. That is actually correct. See here, see when we were discussing about the sliding filament theory, we have to keep in your mind there will not be any change in the length of actin and myosin. There will not be any change in the A band. Okay, so the I band it get reduces and we have discussed that the sarcomeres get reduces, H zone disappears, M line disappears, so that we can say it. But this is actually the correct answer. Actin and myosin filament do not shorten but rather slide past each other. Okay, so that is the correct answer. Keep in your mind. Now the next question, H zone in skeletal muscle fiber is due to H zone. So H zone in the skeletal muscle fiber, it is due to, so the first option, the central gap between myosin filament and A band. Okay, the central gap between myosin filament in the A band. So keep in your mind what is actually H zone. We can see that we already studied that there will be like a Z line, two Z lines are there. Z lines are present between or in the center of I band. Okay, and then we can say that the actin and myosin are actually overlapping, so that region is actually called A band. Now in the center of A band where only the myosin region is present, that is actually the H zone. Okay, now the central gap between the actin filament extending through myosin filament in the A band. Okay, the central gap between actin filament, between two actin filament extending through myosin filament A band, that is actually the H zone. Now extension of the third one, extension of myosin filament in the center part of A band, that is wrong. Extension of myosin filament in the center part of A band, that is not the H zone. The absence of myosin filament or myofibril in the central part of A band, absence of myofibril in the central part of A band, that is also wrong. So the correct answer is actually the central gap between actin filament extending through myosin filament in the A band. Okay, so these are the some of the questions related to the same sliding filament theory. So the sliding filament theory is very important. Everybody have to go through it, especially what are the major changes which is happening during the muscle contraction. Okay, so stay tuned, remaining topic will be discussed later. Thank you.